Good day everyone, welcome to this video lesson, and today we are going to discuss about quadratic functions. What is a quadratic function? A quadratic function is one whose equation can be written in the form y equals ax squared plus bx plus c. The letters a, b, and c are arbitrary constant, and these are elements of real numbers, and a should not be equal to 0. In order for us to fully understand the concept of quadratic function, let us recall first what is a function. So a function is a relation in which two distinct ordered pairs have same first element, meaning for every value of x there is a unique corresponding value of y. So when we say unique in mathematics, meaning there is one and only one value for y. O sa bawat value ni x, may isa lang value kay y. Okay? So that is what we call unique. For every value of x, there is a unique corresponding value of y. So for example, if you have 1, 1, negative 1, 1, 2, 4, negative 2, 4, 3, 9, negative 3, 9, and so on and so forth. So we have to observe the first component or first elements for every ordered pair. So like this one, 1, negative 1, 2, negative 2, 3, negative 3. So as we look at the first elements of every ordered pairs, there is no number that is repeated as first element. Okay, so therefore we can consider this one as a function. Okay, so even though the second element is repeated, for as long as the first element is not repeated, then that's still a quadratic function. Okay, so again, there is no first element that is repeated, so this set of ordered pairs describes function. Okay, we should know also that our quadratic function can be expressed in different ways. So we can express quadratic function by table of values or set of ordered pairs. We can also express this by equation of relation or by graph. How do you know that a function or relation in the table of values is a quadratic function? A relation or function in the table of values is quadratic function if equal differences in the independent variable x produces non-zero equal second differences in the function value of y. So for example, we have this table of values. The first column is the independent variables, values of x, meaning the value of independent variables. The second column is the values of dependent variables, means the y values. So we make sure that in x values, ang bawat pagitan ng mga numbers ay equal. So in this case, equal naman. Ang bawat isa ay ang bawat number ay 1 ang pagitan. So you have negative 2, negative 1, 0, 1, 2, 3, 4, and 5. So kung masatisfied na yung condition na yan, we'll proceed to the dependent variables. So ang gagawin, we have to subtract 0 minus 3, yung magkasunod. 0 minus 3 is negative 3. You have negative 1 minus 0 equals negative 1. You have 0, negative 1 equals 1. Then you have 3 minus 0. You have 3. Then you have 8 minus 3 equals 5. Then 15 minus 8 equals 7. So 24 minus 15 equals 9. So that is the first differences. So they are not equal, they are not the same. Okay, so after the first differences, let's find out the second differences. Ma-minus natin yan ulit. So negative 1 minus negative 3. Okay, so you have positive 2. Then positive 1 minus negative 1, you have positive 2. Then 3 minus 1, you have 2. 5 minus 3, you have 2. 7 minus 5, you have 2. Then 9 minus 7 is 2. Okay? In the second differences, yan. Second differences, yung pag minus natin, equal na. Equal yung second differences. So, therefore, the table of values na pinakita natin, ito ay halimbawa ng tinatawag nating quadratic function. Bakit siya quadratic function? Kasi ang second differences niya ay equal. Okay? So that's it. Okay, let us have an exercises. Which of the following table of values are quadratic functions? So you have the first table, second, third, and fourth. So let's start with the first one. So the interval in the independent variables are same. So every number has an interval of 1. Okay, so we'll proceed now to the dependent variables. So let us find out if this is a quadratic function or not. So we have to subtract. 2 minus 0 is 2. 6 minus 2, 4. 12 minus 6 is 6. 20 minus 12 is 8. So the first differences is not equal. So let's try the second differences. 4 minus 2, 2. 6 minus 4, 2. 8 minus 6 is 2. So the second differences are equal. So therefore, this table of values is a table of values of a quadratic function. Okay. So the second one, so you have 2 minus 0, 2. 4 minus 2 is 2. 6 minus 4 is 2. 8 minus 6 is 2. So, sa first differences pa lang, equal na sila. So, it only shows that this is not a quadratic function. So, this is not a quadratic function. This is a linear function. Okay? So, how about the third table of values? So, 1 minus negative 2 is 3. 4 minus 1 is 3. 7 minus 4 is 3. 10 minus 7 is 3 also. So, same thing on the second table of values. First differences are equal. So, therefore, this is not a quadratic function. This is a linear function. Then, the fourth one, if we verify, 3 minus 12, you have negative 9. 2 minus 3 is negative 1. 9 minus 2 is 7. And 24 minus 9 is 15. So, the first differences is not equal. So, let us verify the second differences. So, negative 1 minus negative 9 is 8. 7 minus negative 1 is 8. 15 minus 7 is 8. So, the second differences are equal or the same. So, therefore, this table is a quadratic function. Okay, so that is how we identify if the table of values is a quadratic function or not. Let's proceed to equation of relation. How do you know that a given equation of relation is a quadratic function? You have to remember that an equation of relation is a quadratic function if it can be written in the general form f of x or y equals ax squared plus bx plus c, where a, b, and c are elements of real numbers. and a should not be equal to 0. For example, you have y equals x squared minus 3x minus 4. Okay, so this is an example of quadratic function because it is written in the general form. Your ax squared corresponds to x squared, so your a is 1 here. If it is 1, we don't need to write 1. Your bx corresponds to negative 3x, then your c, that's negative 4. That's why y equals x squared minus 3x minus 4 is an example of quadratic function. How about this one? 4x squared minus y equals x plus 5. Okay, so this is also an example of quadratic function, but it's not written in general form. If you want to write that in general form, so we have to transpose 4x squared to the right side. So we have to transpose that to the right side, so it will become negative y equals negative 4x squared plus x plus 5. So we transpose this to the right side, so we have to change the sign. And to make the y positive, we simply multiply both sides by a negative 1. If we multiply both sides by negative 1, so we'll come up with y equals positive y equals 4x squared minus x minus 5. So if we multiply both sides by negative 1, so it will become positive. Then this sign will become positive, this one will become negative, and this one is negative. So you have y equals 4x squared minus x minus 5. So it's look like the general form. Okay, so another one, y equals y minus x plus 5 equals the square of x minus 2. So this is again an example of quadratic function. So all we have to do, if we want to write this in general form, we have to expand the product of x minus 2, or the square of x minus 2. So x minus 2 times x minus 2, so it will become y minus x plus 5 equals x squared minus 4x plus 4. So this is the result if you square x minus 2. Then you have to transpose this negative x to the right side, same with positive 5 constant to the right side. So it will become now y equals x squared minus 4x plus x, because this negative x transposed to the right side, so it will become positive x, and this positive 5, it will become negative 5. So we have to combine similar term. So if we combine similar term, we come up with y equals to x squared minus 3x, that's negative 4x plus x, so you have negative 3x. Then 4 minus 5 is negative 1. So we come up to this equation, and this is what we call quadratic function. Okay, so that is how we identify if the given equation of relation is a quadratic function or not. Okay, so let us have exercises. Which of the following equation of relation are quadratic function? So you have x equals y squared minus 5x. You have 4y equals 2x minus 3. Then you have y minus x equal x squared minus x plus 1. You have y equals the quantity of 2x minus 1 times x minus 7. And you have y equals the square of x minus 5, then minus 10. So there are 5 equations. We have to identify which among them are quadratic functions. So let's start with number 1. So the given is x equals y squared minus 5x. Okay, look at the exponent of y. So the exponent of y is an even number. So if the exponent of y is an even number, then the given equation is not a function. So this one is not a function. So ibig sabihin, kasi hindi siya function in the first place, so hindi rin siya, lalo nang hindi siya quadratic function. So not a quadratic function. Okay, so that is just a relation. Okay, how about the second given 4y equals 2x minus 3. Okay, so we have to look at the exponent of the variable x. The highest exponent of the variable x is 1. Okay. If we recall, based on our previous discussion, the exponent of the independent variable must be 2. The highest exponent of the independent variable is 2. So obviously, number 2 is not a quadratic function. Okay. So how about the third? The third one, the exponent of the variable x is 2, the highest, and your y, the exponent is 1, which is 1 is an odd number, not an even number. So therefore, number 3 is a quadratic function. Because if you simplify this one, we transpose this negative x to the right side, it will become positive x. So you have negative x, so makakancel na yung x. So ang mangyayari dyan, will come up with y equals x squared plus 1. So this is still a quadratic function, even though the linear term is missing, the bx. But your ex squared is here, represented by x squared, and the c, which is the constant, is 1. Okay, then the third one is, the fourth given is y equals the quantity 2x minus 1 times x minus 7. So this one is an example of quadratic function. Okay, how do we know that this is a quadratic function? We need to expand the product of 2x minus 1 and x minus 7. Okay, this is an indicated product. So let's find out. If we multiply, will come up with quadratic expressions na yung x, ang highest exponent niya ay 2. So ito ay quadratic function pa rin, kasi pag in-express natin, in-expand yung 2x minus 1 tsaka x minus 7, will come up with y equals 2x squared minus 15x plus 7. Kasi you have 2x times x, so you have 2x squared. So then you have 2x minus 2x times negative 7 is negative 14x. The negative 1 times x, negative 1. So we add negative 14x plus negative x. So you have negative 15x. Then you have negative 1 times negative 7. You have positive 7. Okay, how about this number 5? So number 5 is a quadratic function. Okay, because if you are going to expand this square of x minus 5, you will come up with x squared minus 10x plus 25. Then minus 10 plus 25 minus 10 is equal to 15. So the equation will become y equals x squared minus 10x plus 15. So that is how we identify if the given equation is a quadratic function or not quadratic function. Let us proceed now to the graph of quadratic function. How do you know that a graph of a function is quadratic function? A graph of quadratic function is called parabola. So ang tawag doon sa graph ng quadratic function is parabola. It is a curve that looks like a letter U which opens up or opens down. So this one is an example of the graph of quadratic function. It's opens up. Then the second one is another example of parabola, which is opens down. So meaning the graph of quadratic function, it looks like these two graphs. It's either opens up or it opens down. That's a curve. Okay. Okay, so which of the following is quadratic function and which are not? So the first one. So this one is not a graph of quadratic function. Okay, because as you look at the graph, it does not look like a letter U, right? So it curves, it's down and it's up. Okay, so this is a graph of maybe a cubic function. So therefore, this is not a graph of a quadratic function, not a quadratic function. How about this one? So as you look at this graph, it looks like letter V. So this is not a quadratic function because it looks like letter V. So the graph of quadratic function should be, it looks like letter U, curve. Okay, so this is not a graph of quadratic function. This is a graph of absolute function. Okay, how about this one? So this is now an example of parabola or the graph of quadratic function. So how about this one? So this is not a graph of a quadratic function because it looks like a line. Okay, this function is not a quadratic function. So this is what we call the linear function. How about this one? So this graph, is this a quadratic function? Graph of quadratic function? Obviously, this is not a quadratic function because as I mentioned a while ago, your parabola, it opens either up or it opens down, not opens to the right or opens to the left. So dalawa lang. It's either opens up or opens down. So therefore, this graph is not a quadratic function. How about this one? So this is an example. This is another parabola. It opens up. So this is a graph of a quadratic function. So that is how we verify whether the graph is a quadratic function or not. Okay, so that is our introduction of a quadratic function. I hope you learned something from this concept. Okay, thank you. Until next time for another video lesson.